Good morning, students. In the previous class, we had learned about the emergence of software engineering and the various stages through which the software evolved. The first one was the early computer programming, high-level language programming, control flow based design, etc. So we are seeing all those things on the previous class. And in that, we have seen about how the go-to statements destroy the program's control structure. A good program should have a clear control flow graph. Now, continuing with that, we move on to the next stage of emergence of software engineering. So this is the continuation of the same question, the emergence of software engineering. In this, we see about the structured programming. We learned that the use of go-to statements destroys the control flow graph of a program, and so it is better to use sequence, selection, and iteration types of control structures in the statements. So using control flow diagram or control flow graph to maintain the better path of a program, we make use of the sequence, selection, and iteration types of control constructs in the program. So a program is called structured when it uses only the sequence, selection, and iteration types of constructs and is modular. So a structured program will always have a clear path. There will not be any complex path in that program when it makes use of sequence, selection, and iteration types of constructs in it. And that program will be always modular. What is a modular program? A modular program is one that is decomposed, and that could be decomposed into a set of modules such that the modules should have low interdependency among each other. So that is, we could split the program into separate modules. The modules have low interdependency. So we can completely split the program into different parts or modules without much dependency among each other. So this is called structured programming. So the programs could be separated into modules, and each modules are developed separately. So the features of structured programming are it could avoid the unnecessary use of go-to and jump statements, which destroys the clear path of a program. So we can either completely avoid or reduce the use of go-to and jump statements, and it uses single entry, single exit control statements. So by avoiding the go-to and jump statements and making use of the sequence, selection, and iteration type of controls, we could use only a single entry, single exit control statements such as if, then, yes, checking for a condition using the if statement, and if the condition is not met, the else part will be considered. So there will be only a single entry to that loop and a single entry from that loop. Or we can use the do while statement, the same purpose. And the programs are always modular. When we use the structured programming, we use the structured control structures. The programs are always modular. That means the program can be decomposed into modules with low interdependency, and they are less error prone. Using the structured programming techniques, the programs are always less error prone. There is low chance of an error, and the programs become more readable when we use the control structures in our program. That means there will be a simple path in the program. So using a control flow graph, we can easily identify the path of a program so that the program becomes more readable. That means we can identify which process is going on, or what is used, how the input values are converted into the output values. We can recognize it easily. And the structured programming, when we use the structured programming, the programs becomes easy to maintain. When a program is easy to understand, the program will be easier to maintain also. And it uses only, it needs a less developmental effort, only because we can state the problem clearly, and we can state the design process clearly, and it uses a simple path from one module to another, and we can easily identify the flow of execution, the sequence of execution from one module to another, and in that particular module. So the developmental effort will be lessened even further using the structured programming. The next one is the data structure oriented design. The next stage in the emergence of software engineering is the data structure oriented design. So with the use of integrated circuits, as more powerful integrated circuits, and this data structure oriented design was evolved during early 70s. At that time, there is a need to solve more complex problems. So when they have to solve more complex problems, when they need to face more sophisticated problems, they need to develop larger and more complicated software products also to meet with their requirement. They have to write programs in excess of several tens of thousands of lines of code, and the existing structured programming techniques does not provide provisions for writing much larger source code. So they need to pay attention to the design of important data structures of the program than to the design of its control structure. So they move on from designing the control structure, and they pay more attention to the design of the important data structures of the program. So first identifying the data structures used in that program, and then design the data structures, and the next step was to design the program techniques. So using the data structure oriented techniques, first a program's data structures are designed, and then the program design would be derived from that. So first discovering or identifying the data structures, important data structures used in a program, and then deriving the program design from the data structures. This is the process of data structure oriented design, to identify the important data structures used in that program, and then to design the program using the data structure. So using data structure oriented design techniques, first a program's data structures are designed. The code structure is designed based on the data structure. So the main features of the data structure oriented design are designing of the data structure. So identifying the important data structures of the program and designing the data structures. And it uses more powerful integrated circuits. So the system overall hardware is more powerful. They got a more powerful hardware for doing more complex problems. And these data structure oriented design, by identifying the important data structures on that program, we can solve complex problems also. It so that it can be used to write programs that exceeds tens of thousands of lines of code. That means we can write larger lines of code. It can be used to solve more sophisticated problems. And the development of more complex softwares, it supports the development of more complex softwares using the data structure oriented design. Then the next stage of emergence of software engineering is the data flow oriented design. The data flow oriented techniques uses an idea of forming the major data items in the program. Before going on to the program design or data structure design, we first identify the important data items that is used in a program. So it uses the technique of identifying major data items handled by the system, and then the processing required on these data items to produce the desired outputs. So first, identification of the data items that is used by the system, and then to determine the process through which the data items should be processed. So first identifying the data items and then going on to the functioning or the processing of that data items. Processing means how the input data should be converted to the output data. That is defined as a process. So from the data flow oriented design, we make use of the term process to identify the functioning of that software. So a software may make use of several functions, and each of these functions were termed as separate process. The separate process makes use of separate data items. The data items may be, the flow of that data items may be from several modules. So the basic thing of data flow oriented design is that to identify the important data items used in that program, and then to determine the processing, that is the functions of each of the data items, how the data items are converted to output values. Of course, this technique was evolved by the introduction of very large scale integrated circuits. So with the evolution of faster, more powerful, very large scale integrated circuits, new architectural concepts and more complex and sophisticated software products will need to be solved. So as they face more challenges, the more the emergence of software engineering would be happened. So as a result of the development in the very large scale integrated circuits and the need for solving more complex problems, they derived at an idea of forming data flow oriented design. So using this technique, we use data flow diagram to represent the flow of the process or the flow of data items through the process. So like that, when we used on the control flow structure, we used a control flow graph to represent the control flow structure path of execution of the program. And like that, here for use of data flow oriented design, we make use of the data flow diagram DFD to represent the flow of controls. So overall data flow is represented by the data flow diagram, in short DFD. In the figure, you can see a simple DFD. The DFDs are always more generic. That means the symbols used on the DFDs are more generic. They are common to all software systems. So, but we shall see the different symbols used in the DFD in deep in the later sessions. Now, let us see. Let us have a look at the simple DFD used in a engine store. The whole representation of the workstations, assembly line, etc. So how simple the representation is. So the various symbols can be seen in the later sessions. We shall move on to the Next one, object-oriented design. The object-oriented design, the OOPS techniques are more familiar to you. Now, in object-oriented design, we try to first identify the objects. That means the real-time items are extracted as the objects in a program. So using the object-oriented design, we first identify the objects that are important on that program. Identification of objects relevant to the program problem and establishing relationship among the objects. So first, to identify the important objects that might be used on the program to solve a particular problem, and then once the objects are identified, then form a relationship between the objects, forming or establishing relationship among that objects. First, identifying the objects. Second, establishing relationship among the objects. You know what may be the relationships. That means we can establish a relationship among the objects using composition, reference, inheritance, etc. So object-oriented design needs a programming language that facilitates the use of relationship among the objects. And this was facilitated with the development in C++, etc. The most object-oriented programming languages that provides more provision for making use of the concept of identifying the objects in the program and then identifying or establishing their relationship among the objects such as composition, reference, and inheritance. And then using the object as data hiding or data abstraction entity. You know what is data hiding or data abstraction entity? Using the object-oriented concept, we can form different objects or the process of certain modules as a particular unit. As a single unit, we can form particular data items as well as the data process as a particular unit using the data hiding techniques and data abstraction techniques. You may be you're familiar. I think you are familiar with all these object-oriented concepts that you have learned already. So it uses these concept of objects, relationship of objects, and this makes use of more terms such as data hiding, data abstraction, polymorphism, etc. You know the main concepts of these polymorphism, inheritance, etc. are to provide reusability of code. So of course the advantages of object-oriented design is that it uses simple technique that is more readable, more understandable, and of course it is more easy to maintain. So it uses a very simple technique, and the scope for code and design reuse, there is a scope for reusability, and reusability is the more important advantage of using the object-oriented design. And for that we use the terms polymorphism and inheritance. And it has a lower development cost. The software becomes more expensive, but using these techniques the development cost can be lessened, and it uses robust code that is easier to maintain. So these are all the advantages of the object-oriented design. And as a summary, we shall see what we have learned on the emergence of software engineering. As we said earlier, software design techniques have evolved since the early days of programming from 1950. So from that early days, we use an exploratory style of programming, and then with 60s, in early 60s, we know the programming style uses the control flow oriented design, and in early 70s, data structure oriented design style You know what is the difference of this these stages? We have learned it on the previous classes. Exploratory style, that means just building, build and fix style. That is just build up a program without much planning or without having much strategy. So without a strategy plan or design, the program is quickly developed, and then the then fixing of that program. That was the older, much earlier method of programming that is used in early 50s, and in early 60s we came to know about the control flow oriented design that makes use of designing the software by identifying the flow of execution from each statements in a software. And then in 70s, data structure oriented style was about, you know, data structure oriented style that we seen today. It identifies the data structures, important data structures in a program, and then deriving at the program design. And in 1980s, the data flow oriented style was evolved. Data flow oriented style, we see that in the data flow oriented design, we try to understand the data items in a program, and then we form the process through which the desired output will be it. And then from 2000 onwards, we have the object oriented style. On that, we form the objects and then determine the relationship between the objects. And we heard several object-oriented programming languages that facilitates the use of data hiding, data abstraction, polymorphism, inheritance, etc. And what's the next? What will be the next? So of course we are now using we are using the current technique as a client server environment through a web browser. There is a current technique we are making use of, and we have the challenges. We have certain challenges also nowadays. The current challenges in designing software products. First one, maybe the program size. The program sizes are further increasing comparing with the earlier days. And the second one is, as we said, the client server environment that is being used of. And the small handheld devices and the embedded processors that are being used. So there may be, or nowadays we know we are making use of the cloud computing, etc. Newer techniques are evolving. So as years pass on, we may see further more developments in the software development area. Okay, we shall continue in the next session. Thank you, students.